Here we have this pulley problem. So there's two pulleys on the top, which are connected to each other and also connected to the ceiling, which will not move. There's two pulleys at the bottom, which are connected to each other and also connected to this box. Now, connecting all of these is this cable here. You're going to pull down this cable. It loops around this top pulley, then down and around this bottom pulley, then around the second top pulley, and then around the second bottom pulley, which then this rope will connect to this stationary object, the ceiling, and will not move. So as you pull this rope down, you'll bring these two pulleys in the box closer to the two top pulleys. And it ultimately wants us to find the minimum force required to lift this box. So I'm going to draw a quick free body diagram. Since we said that the box as well as the two pulleys are going to get lifted, I'm going to draw that. Now this box is going to have a force of gravity that points down. Now, force of gravity is equal to mg. Now we have to figure out what the mass is. Well, it tells us that the mass of the box is 410 kilograms. And it also tells us that each pulley has a mass of 6 kilograms. Since there are two pulleys that are going to get pulled up, this will be 12 kilograms. So the mass that's going to be pulled up is going to be 422 kilograms. All right, now we have to figure out what force is getting pulled up. Well, this cable loops around. And if you notice, it's all one cable. So the tension, I'll call it FT, this will be FT, is going to be the same throughout this entire cable. So we have to look at how many ropes are connected from these pulleys, these two pulleys at the bottom, to the top. Well, we have one rope here, we have another rope there, we have one rope here, and another there. So there are four total ropes. So I'll say there are four forces of tension that go up, and this is going to have to equal the force of gravity. This just comes from saying, let's just say up is positive. We'll say that the acceleration is 0. It wants us to find the minimum force required to lift the box. So the acceleration is actually, 0.0001. So we'll say F. Since I said up is positive, it'll be the 4 F of tension. It'll be minus the force of gravity, because that'll be negative, will be equal to 0, because it was said that A is basically 0. So we'll get a 4ft is equal to Fg. What do I have there? Awesome. So now, force of gravity is mg, so 4ft will be equal to mg. This will be the mass of 422 kilograms, so 4 times the force of tension is going to be equal to 422 kilograms times 9.8, which is the acceleration of gravity, divide 4, and we got that the force of tension, the force needed to lift the box, will be equal to 1,034 newtons. We also need to find what minimum length of rope that we need to pull to lift this load 4 meters above the ground. Well, if you see, you pull this rope here, and it wants us to find how much rope you need to pull out in order to lift this box 4 meters. Well, we'll say that the work needed to lift this box will be the same as the work needed to pull this box. So I'll say this is work of tension. Now, this kind of makes sense because you have to put in work to pull this box, and this work is transmitted through this rope to lift this box. So we can say that the work to lift this box, which is done by all of these tensions directly on the box, will be the same as the work needed to just pull this end of the string. Now, if you remember, work is equal to force times distance. I'll call it F delta x. So the work needed to lift the box will be 4 times the force of tension, because again, there are 4 ropes that are going to pull this up, times the distance. I'll call this d. This d is going to end up being 4 meters, because we're lifting this box 4 meters. It's going to be equal to the force of tension that you're pulling this rope. I'll call this delta x, which is what we're solving for. So this force of tension is going to cancel with that. We'll get 4 times the distance of the box will be equal to delta x, the distance we need to pull this rope. D is 4, so it'll be 4 times 4 is equal to delta x. Delta x will be equal to 16 meters. So you're going to need to pull this rope 16 meters to lift this box up 4 meters. So those are our two answers. Thank you for watching.